Hi doctor, my name is AGILAN. This is our PBL2 group assignment. Our group is group 1. Today I will present our introduction and filler table. For introduction, we got the complete this assessment by using we gain in the knowledge from chapter 4, pulse code modulation PCM. First of all, problem-based learning is a student-centered approach to learn which student gain knowledge of a subject by functioning as a team to resolve open-ended problem. Furthermore, the root of motivation and learning lies in this problem. Filler table can be used to summarize information, concept, problems with learning helps with the answer of the task. More students then presented with a selection of technical specifications, limitation, sampling beats, sampling rate, analog modulation for PCM, and finally the act of modulating signal. This was our group filler table. First was facts. Pulse code modulation is a technique that applied to a digital represent samples. Then ideas, learning issues, and action plans. For ideas, we need to complete a mix of modified analog signals can be transmitted through the digital communication network. Learning issues can be find the suitable method for the given problem, effect of PCM. Action plans refer to any sources related to pulse code modulation method. The second one is basic element of PCM, and the sample rate is the number of sample sound taken per second. For third is the PCM word size can be described. The number of quantitation level that is used for each sample. How to avoid or reduce the magnitude of quantitation distortion. The fourth one, the pulse code modulation procedure can be completed by 3 steps: sampling, quantitation, and coding. Analog waveform of the transmitter and source of a circuit will provide the pulse code modulated waveform. What can we do with pulse code modulated? Why pulse code modulated is important? We can surf the internet about the information. That's all from me.
Hi, Assalamualaikum. And my name is LIYANA binti ABDUL, and my metric number DE10047. Okay, I would like to explain to you about this problem statement, which is part A. Part A that we use this PCM encoding and decoding in MATLAB Simulink. And then for part A, I have two scenario, which is 4 bits and 8 bit. So I would like to show you 4 bits. Okay, this is our diagram, and then we click run. Okay. Okay, for bit show that this is the output for the diagram, and for color of yellow is MSB and red for bit 3. Okay, and then the oscilloscope like this. I'll put the wave frequency wave, and then before that we need to change the bits for bits and decoder for bits. Okay, for part 8, part A 8 bit, and then we run. So we change the 8 bit because you were using 8 bit, and then this is all the diagram, and then it show the output. Okay, like this. So we use 8 bit, and then so that the output will be have MSB bit 3, bit 2, LSB, DMAX, DMAX 7, DMAX 8. Okay, for the oscilloscope, the frequency like this. Okay, and then the scope for the diagram like this. Then the scope 1. Okay, the modulating signal, and like which is like red purple color, and the sample hole like green color. For the 8 bit we use 8 bit, and we change the uniform encoder, and then we change also the uniform decoder, and then analog so that we can get the output. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I'm ADILAH MAIZAN binti MOHAMAD ZULKHAIRI. So today I'm going to show the simulation for part B. So in part B, we are required to give a sampling for MT that is more than the required according to the Nyquist, which is frequency sampling must be more than 2 FM. So For this, for our group, we have set the modulating signal to be the frequency for modulating signal to be 2 pi 1000, which is the frequency sampling will be more than 1000, which is 2000, and then the amplitude is 2.5. Also for the sampling pulse signal, we have set the amplitude for 2.5 and the period is 1 over 10,000. So, and then for the first scenario, we have to use 4-bit encoded PCM data. So we have used the 4-bit encoded PCM display to show the wave for the 4-bit encoded PCM. So when we run the simulation, for the first scope, here is the connection of modulating signal and sampling pulse signal. So here is the modulating signal, which is the input signal. So the amplitude also 2.5, from 2.5 to negative 2.5. And then the sampling pulse signal is like this. And then for the second scope, here is the connection after the uniform encoded and the modulating signal. So since we use 4-bit encoded PCM data, the quantization level here at the uniform encoder should be 16 level, because it's actually the level is actually from 2 the power of n. N is actually 4 bit. So it should be 16 quantization level, and we can see here it starts from the 0, which is the encoded level should be always positive, start from the 0 to the 16 level, and each of the level is actually referred to the sample that we take from the quantization voltage that has been rounded off to the nearest quantization level. So this is the way for the quantization process, and we can see here that size step for each quantization level is different and much more bigger. So we can say that the bigger the step size, the more accurate the signal will be. And then the next one is the 4-bit encoded PCM display. So this will show the process from the LSB to the MSB, that being the signal being encoded. So we can see in four different types of encoded process. From the LSB, here it's much more faster than the MSB, being encoded from 1010. And then the last one that we want to see is the recovered modulating signal here in the oscilloscope. So this is the recovered modulating signal that have been through the process of modulating, and then the frequency is actually nearest to the 100 Hz, and the time taken for one cycle is 1.007 millisecond, which is quite fast. And then the next one is for the 8-bit 8-bit sampling frequency. And here for the modulating signal, also we have set it to 2 pi 1000, which is the sampling frequency will be more than 2 FM. And then we have set each of the encoded bits, uniform encoded to 8 bits, also the uniformly decoded to 8 bits, and analog filter designed to 8 bits. And then the next scope, it showed the uniform encoded wave and also the modulating signal. So here we can see that the quantization level is actually starting from 0 to 250, since it is 8-bit PCM encoded data. So the quantization level, the level should be 2 the power of 8, which is 256. So here it shows exactly from 0 to the 250. The level of each quantization also based on the quantization voltage that being rounded off to the nearest quantization level number. And then next is the 8-bit encoded PCM data display. So it shows the starting from the MSB to the DMUX 8. So we can see the type of the process being modulated from 1 to 0, from MSB to the DMUX and then decoder. So it will show the signal, sine wave signal, with the frequency of also nearest to the 100 hertz, 1000 hertz, and also the time taken for one cycle, 1.004 millisecond, which is, yeah, that's all.
Good afternoon, doctor. My name is HAARISH, Kumar, son of LETCHUMANAN, and my matrix number ECE200171. And now I'm going to present about the Part C of our group project. As we know, the main requirement for the Part C is the sampling frequency should be less than 2 FM. This is the block diagram that we have done. Once we finish the block diagram, we can monitor the waveforms. First of all, we need to run the simulation. Okay, done. Now we can check the waveforms. The first one is modulating signal and sample and hold signal for 4-bit encoded PCM. This is the waveform. And the next waveform is modulating signal and uniform encoded signal. Okay. The next is 4-bit encoded PCM, fs lower than 2 FM. Okay, this is the waveform. And the last waveform is the recovered modulated signal for 4-bit encoded PCM, fs lower than 2 FM. Last but not least, if we compare the part A, B, and C, we can notice that the part B, which is done by multimedia, can produce a strong signal compared to others. This is because the part B consists of bigger step size for each quantization level. As we know, the more the step size, the less the quantization noise. Okay, that's all from me. Thank you very much.
Selamat sejahtera doktor, my name is Beijing and my mention number is CE20093. Today I'm going to continue the presentation for part D. What we're going to do for part D is, the question state that we are going to still using the part B setting, and we are going to change amplitude value from 2.5 volt to 50 volt and also 0.5 volt. And then we are going to observe the output of the sample and hold 2 at the receiver path. Okay, this is the output that I obtained from the Simulink MATLAB. Then we're going to run the PCM system with 4 bits and also 8 bits. So now let's go to the simulations of MATLAB. I'm going to do the simulation for 4 bit using the 50 volt and 8 bit using 0.5 volt. Okay, so this is the part B circuit that we draw for PCM system. So now we are going to change the amplitude to 50 watt. Oh yeah, well, we are going to use the period is 1/2500. This is because for part B we are going to use the value of sampling frequency that is larger than the larger than 2000. Okay, where it comes from the 2000 if is the value from the modulation signal. Okay, for sampling frequency we are going to will be twice of the modulation signal. So that's why I'm going to use 2500, which is larger than the value to the actual sampling frequency is 2000. Okay. This scope shows the modulation signal and also the sample and hold one waveform. Okay, now for scope 2, for the top one we'll be showing the sample and hold 2, the waveform that come out from the sample and hold 2, and also the recover message, the recover signal. So from here we can see that we can compare from the input, the modulation signal is similar with the recover signal. We get the same sine wave. Now I'm going to run for the 0.5 volt. The step is also the same as this, but now we're going to change it to 8 bit. For this, for 0.5 volt, you also get the same, which the modulator signal pattern is like this, and finally the recover signal, so you get the same as the modulation signal. The difference in this is you just change the amplitude value for both from 2.5 to 50 and 2.5 to 0.5 volt. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad HAKIM NADZRUDDIN. My metric number is DE10136, and today I will talk about the conclusion for our group assignment. So the conclusion for this assignment is the theoretical knowledge we learned in chapter 4 must be used to complete problem-based learning, which is PBL assignment. However, as we analyze various type of electrical noise, analyze this digital modulation method used in communication system, and solve the pulse code modulator circuits digitization of the analog signal. Next, we summarize the facts, concept, problem-based learning, and action using the FILA table as a guide for us as we propose a solution for this task. From the observation, a digital technique called pulse code modulation, which is PCM, involves periodically sampling an analog signal and encoding the observed amplitude into a string of binary values that we are then modulated into a pulse code signal that is then delivered. Therefore, in this assignment, we utilize a method that transforms analog signal into digital form. And lastly, we were successful complete this simulation using MATLAB simulating with the guidance of lecturer. And next, we talk about flowchart brainstorming process. So first thing for flowchart, which is start, and after that we discuss the problem based learning, which is PBL, and next analyze the problem statement. After that, we provide the answer for the task given from scenario 1 until scenario 5 by doing MATLAB simulation. And the next process, which is simulate the coding using MATLAB. And after doing MATLAB, we differentiate the simulation with calculation. See the simulation result are same or not with calculation, manual calculation. And after that, we find out the result. And lastly, which is end. So that's all from me. Thank you.